Afternoon all. Yes, I'm Ruth Williams. I'm Head of Marine Conservation at the Wildlife Trust, and I'm here today, I've lost the clicker, here today to talk to you about blue carbon and how we need to better recognise the value of our seabed in particular for both its nature and its climate benefits. The Blue Carbon Mapping project that I'm going to talk about is the world's first assessment of the carbon storage and sequestration potential of UK seas. It was quite a feat, and I must stress that I'm here on behalf of the wider partnership of the Wildlife Trust, WWF and RSPB, not just as the Wildlife Trust. I think in this room we all know what blue carbon is, but just in case, blue carbon is the term for any carbon that is absorbed and stored in the ocean, in its habitats, in its animals, in its plant tissue. And up until recently, and primarily based on the original IUCN definitions, blue carbon habitats have focused on these three coastal vegetated habitats: seagrass, salt marshes and mangroves. But there's one key one missing. Mud, glorious mud. I'm not going to sing, there's no singing hippos here, but our UK wildlife, like our waders, our nephrops, our flatfish, our sea pens, all think that mud is awesome. And we need to change our thinking a little bit to the same. And the work I'm going to show today hopefully will explain a little bit more why. We have only just scratched the surface of our knowledge of the sea floor. That old adage, we know more about the surface of the moon than we do about our seabed. But we are starting to build a much clearer picture now of how carbon, biodiversity and human activity interact under the waves. And it's with that knowledge that we can make some much more informed decisions that support a sustainable future for nature and the climate. And this work goes some way towards that goal. So this current mapping project builds on some innovative work that was undertaken in Scotland in 2014 and 2017. And subsequently, the blue carbon assessment work of the North Sea, which was completed a couple of years ago in 2021. And these projects showed that, whilst difficult, these assessments could be done. And so the Wildlife Trust, WWF and RSPB commissioned the Scottish Association of Marine Science, SAMS, to undertake the work to map the extent and distribution of all of our blue carbon assets and stores in the rest of the UK. No mean feat, as I've said before. It was very much a partnership project, and like my brittle stars there say, many arms make light work, or lighter work at least. And this very much was partnership between those three NGOs, but with special thanks to Bex and Danny Clifford, who's up here as one of the young awards shortlisters last night, who really helped project manage this and keep us all herded together and get this thing off the ground and finished. We were also really lucky to have two expert advisors in the forms of Professors Dan Foley and John Baxter, and also an independent advisory group, which really helped to support the delivery of the project and also to ensure cohesion with some of the other government initiatives on blue carbon. So how did we do it? I'm fairly new to this, so I didn't do any of it. I'll put my hand up, or not very much of it. And I'm not a carbon scientist, so I may not be able to answer any specific carbon questions later on, but I can pass them on if needed. The research was undertaken in stages over 3 years, and it was divided into the regional seas that we see here: the English Channel and Western Approaches, Irish Sea and the Isle of Man, Scotland, and then a whole UK-wide assessment too, to produce this comprehensive inventory of all blue carbon habitats across the UK and Isle of Man exclusive economic zone and out to the continental shelf. We mapped the extent and distribution of all of the blue carbon habitats. We assessed the quantity of carbon stored in each and the average sequestration rate per year, so how much carbon accumulates each year in each sediment type. So how much, oh, forgot to click. Bear with. How much is down there? Well, 244 million tonnes of organic carbon is stored in just the top 10 centimetres of our seabed. Over 98% of that carbon is in these seabed habitats, and that covers 885,000 kilometres squared, and that's over 3 times the size of the UK's landmass. And up to 13 million tonnes of organic carbon is added annually to these sediment stores. and that's about 3 times as much as our UK forests, which accumulate an estimated 4.8 million tonnes per year. But I just want to stress that this is really the very tip of the iceberg. There's an awful lot of mud down there, and this assessment only looked, like I said, at the top 10 centimetres, and mainly because that's where the data we have is primarily for, but it's also in those top layers that are most at risk of impacts. So these figures that I'm presenting here today are huge underestimates in terms of carbon stored. There's a huge amount more sediment, hundreds of metres of it beneath. But what about the rest? In terms of coastal vegetated habitats, these habitats, kelp, seagrass and salt marshes, cover just 1% of the UK seas, but they contain 1.7% of our organic carbon. There's 286,000 tonnes of particular organic carbon that is accumulated per year, and 60% of that is in our salt marshes. This box shows the habitat-specific values and shows really the sort of puts it into context that the seabed sediments are 240 million tonnes, several orders of magnitude above our salt marsh and seagrass and the seaweeds, the algae. And I just wanted to sort of stress that whilst these coastal habitats are more visible and more media friendly, I guess, they are important for those, but they only provide a very small proportion of our wider carbon stores when compared to mud. And going back to this chart, we also looked at how much carbon was stored both within and outside of the MPA network. And interestingly, 43% of our carbon is already stored within our existing MPAs, which leads me on to the next part of the story. Unsurprisingly, the biggest threats to our blue carbon are activities which disturb the seabed, things like bottom trawling and developments. And both of these activities impact that seafloor, disturbing the carbon-rich sediments and potentially releasing carbon back into the water column and into the atmosphere, worsening climate change potentially. And in terms of offshore renewables, this is potentially a really complete own goal. So it's great to know the science, but what needs to change? So collectively as a partnership, we've come up with some recommendations, some asks that we're putting out there. First of all, we need to make sure that all of our MPAs are protected from destructive activities that damage these blue carbon habitats, as well as threaten marine life. As we know, many of our designated MPAs do not currently have adequate management measures in place, and they still allow destructive activities to happen. We don't allow ploughing of our peatlands in protected sites on land. Why are we still allowing, essentially, ploughing of our seabeds in marine protected areas? We need to improve strategic planning of activities in the UK seas. We need blue carbon to be embedded within marine spatial planning, and all activities should be strategically planned to reduce and avoid disturbance to these areas, and where that isn't possible, to minimise the impacts. We need blue carbon in environmental impacts assessments, and that will help to clarify and incentivise industry to avoid and minimise those impacts and find innovative solutions to unavoidable impacts of developments where we can. We heard quite a bit about a just transition in the last session. People eat fish, and we export large quantities of fish, but we have to learn how to do this better and to transition to more sustainable methods that are more in balance with the natural environment, that same environment that supports those fisheries. And more investment and research is needed. There's still really big gaps in our knowledge, and this report has really highlighted that. We need to better understand the carbon flux and dynamics within the whole system better, and that means more investment and research on blue carbon to help our learning and our restoration efforts. Some of this is already happening, but we need to do more. So our quick take-homes, please read and share our reports. They are online, and there are some still down in the marquee if anyone wants to take a hard copy home for the train. Mud is great, and it's a huge carbon store. MPAs contain 43% of our organic carbon, and we need to protect them far better. We need to include our blue carbon in marine planning to avoid and to minimise impacts, and we need to learn more to fill those gaps. So just to finish, back to that original question that was posed for this session, can we achieve well-managed and restored marine and coastal seascapes by 2030? It's getting less and less likely, but I am an optimist, so I'm going to say yes, for the well-managed bit anyway. The potential is really there. I just worry sometimes that the urgency and the political will isn't. Results from projects like this need to be used to raise the profile of the ocean as a nature-based solution to climate change, as well as nature recovery, and crucially to inform decisions on the use of our ocean and action those decisions now. Ocean action can be both and needs to be both climate and nature action. Thank you.